Welcome back, everyone. Thanks for coming. What I'd like to do now is build on what we talked about in the last lecture, but now instead of reporting cumulative incidence and estimated risks, I want to turn those into odds and report odds ratios, and then say a few words about an odds ratio as a measure of association. So here's the data we had last time. We had followed 100 people, 100 students like yourselves in this class. 50 of them were men, 50 of them were women, and we observed that 10 of the men developed headaches and 5 of the women developed headaches during those 7 days of follow-up. But now what I want to do is not report the estimated risk of headaches among men and women, but the odds of developing headaches among men and women. Now remember, what the odds represent is a pot divided by a non-pot. So the odds of developing headaches among the men will be the 10 cases of headaches divided by the 40 people who didn't develop headaches. 10 over 40 would give you a value of 0.25 as the odds of developing a headache if you're a male, based on these data. Among the 50 women, 5 of them developed headaches and 45 of them did not. 5 divided by 45, the odds of getting a headache for a woman, 1 out of 9, gives you an odds of 0.11. So that's the odds of developing headaches for men and for women. Now, if you want to build in a measure of association, we could develop a ratio. We could divide the odds of headaches among the men, 10 divided by 40, divided by the odds of headaches among women, 5 divided by 45, giving us a ratio of 2.25. How we interpret this odds ratio is similarly to how we interpreted risk ratios. It's how much you have to multiply the odds of getting a headache for a woman to obtain the odds of getting a headache for a male. So it's a multiplicative factor again. The odds of headaches for men are 2.25 times that of women. And notice the value for the odds ratio is different from the value for the risk ratio that we had in the previous lecture. Risk ratio was 2.0. The reason being we have a different outcome measurement here. We're measuring an outcome based on odds rather than proportions, rather than estimated risks. Well, odds ratios are commonly used in epidemiologic studies, and Marcello's pointed to this a few times. There are a couple of situations where the odds ratio becomes the preferred measure of association. In a few weeks, we'll be talking about different study design options, and one of the options we're going to be talking about is something called a case control study design option. And you'll see then that the odds ratio is the only natural measure of association to report. So for case control studies, odds ratios are the most common, probably the most appropriate measure of association for reporting. Now for a cohort study, which we just talked about, following 100 students for 7 days, in a cohort study we could measure risks or odds if we have no losses to follow up, no losses due to competing risks. So there's nothing wrong in reporting odds of developing an outcome among the exposed, the men, and among the non-exposed, the women, as in the previous example. So for cohort studies, it's an option to report an odds ratio. Now, the second time you'll see odds ratios reported is determined by the type of analysis you might be doing in your study. If you're doing something called a logistic regression model analysis, and we'll talk about that at the very end of this course, then it turns out when you fit logistic regression models that your measure of association that pops out of your printout, the one you report, is again going to be an odds ratio. So there are some situations either based on the study design, case control studies, or maybe by choice for a cohort study you can report odds. And there are other situations based on the analysis when you're doing logistic regression modeling, where the odds ratio is typically the only measure of association you can report. So it's commonly used. One nice feature of odds ratio, though, is it's a very symmetric measure. It's symmetric on at least 3 different levels, and I'd like to just say a few words about odds ratios and the fact that they're symmetric. One is based on just the symmetry of the odds itself. Now, one of the dark sides about being an epidemiologist is we measure outcomes, and the outcomes are usually disease outcomes. If you remember in the previous example, I was focusing on the odds of developing a headache. Well, why not be more optimistic? Why not develop the odds, or report the odds of not developing a headache? Well, it turns out that if I gave you the odds of developing a headache and didn't give you the data, you could calculate the odds of not developing a headache by just flipping the number I gave you. The odds of not developing disease is always equal to 1 over the odds of developing disease. So, for example, in the previous example, we were focusing on headaches, and I was reporting the odds of developing headaches, 10 divided by 40. Well, the odds of not developing a headache is just the inverse of that, the flip of it, 40 divided by 10. For men and for women, before the odds of developing a headache was 5 out of 45. Now it's being flipped. For the odds of not developing a headache, it's 45 over 5. So first of all, the odds are symmetrical in terms of if you take their inverse, for any odds you calculate, the inverse of that is the odds of not developing the outcome, not developing disease in this particular case. Another nice feature, even more importantly, is that the odds ratio itself is flippable. Again, if we weren't focusing on the bad outcome, developing a headache, but rather would want to focus on the good outcome of not developing a headache, and I calculated the odds of not developing a headache as I did in the previous example. The odds of not developing a headache for a male, 40 over 10 is 4. The odds of not developing a headache, 45 over 5 is equal to 9. I could take the ratio of those two numbers to get the odds ratio for not developing a headache. Well, it turns out that that's just the inverse of the previous odds ratio. The odds ratio for not developing an outcome is 1 over the odds ratio of developing the outcome. So before we said that the odds of developing a headache, remember, was 2.25. If I took the inverse of that, 1 over 2.25, I'll get this number 0.4444, which is numerically equal to taking the odds of not developing a headache for the men, 40 over 10, dividing that by the odds of not developing a headache for the women, 45 over 9. So if anyone gave you an odds ratio from a study as the odds ratio for developing a disease for exposed people relative to non-exposed people, the inverse of that odds ratio would be the odds ratio for not developing disease for exposed people compared to non-exposed people. So that's another nice symmetrical property of odds ratio. The third one is even neater in terms of it ties cohort studies into case control studies. It turns out that if I gave you a 2x2 table, like the one we were just looking at, up until now we've been looking across the rows of the table. We've been talking about the odds of developing disease or the odds of not developing disease. It turns out that if I look down the columns of a table, I could look at the odds of being exposed, of having the exposure for people who had the disease versus who didn't have the disease. And it turns out that if I gave you a 2x2 table and I asked you to measure odds and odds ratios, and one of you looked across the rows and reported the odds of developing a headache of men versus women and took the ratios of those, that would be an illness odds ratio or a disease odds ratio, odds of headaches among men versus women. But if another person looked down the columns of that table, looked at among all the people who had headaches, looked at the odds of being exposed, the odds of being a male, compared to the odds of being a male if you were in the other column, the non-headache column, you're going to get the same answer. And to see that, let's go back to that 2x2 table. Here's what we've done so far. We've been reporting odds of getting disease. Among the men, it was 10 headaches divided by 40 non-headaches. Among the women was 5 out of 45. If I wanted to, I could take the same table and ask an entirely different question. Among people who got headaches, there were 15 such people in total. What was the odds of being a male? It would be 10 divided by 5. Among the people who didn't get headaches, there were a grand total of 85 people. 40 of them were men, 45 of them were women. What's the odds of being a male among them? It would be 40 divided by 45. So notice the odds of being a male are different from the odds of developing the headaches. The odds themselves are different. But if one of you takes the ratio of the odds of having disease, what we did before, take the 10 out of 40 odds among men and divide it by the 5 out of 45 odds among women, remember we got an odds ratio of 2.25. Now if I calculate an exposure odds ratio, the odds of having the exposure, odds of being men, among the people who got disease, it would be 10 divided by 5. if I divided that by the odds of having exposure among people who didn't get disease, the 40 over 45. It's still an odds ratio, but it's an exposure odds ratio. Numerically, what I'll get for an answer is the same number, 2.25. Meaning for data like this, if you're trying to measure the association between the row variable and the column variable, and one of you starts by fixing the rows and looking at the odds of having one of the columns, the disease column, being disease among people with headaches versus without headaches, and takes the ratios of those. And someone else looks down the opposite, looks down the people who have headaches and people who don't have headaches, and talks about the odds of being a male, being exposed. If both of you take the ratio of your odds, you're going to come up with the same answer. Both of you are going to come up with the number 2.25. Now that's going to be important in a week or so when we talk about study design and when we talk later about case control studies. Because it will turn out that when you do case control studies, if I go back to the previous slide, what we do is we start out with people who already have the disease, already have headaches. We start out with other people who don't have the disease, people who don't have headaches. We ask about their previous exposures, what could have caused their headaches for this group of people and not caused it for the other group of people. We measure exposure odds. We take ratios of those exposure odds. We report an exposure odds ratio from that case control study. Well, it's linked numerically to the disease, the illness odds ratio in that previous slide. So it's a way to link case control and cohort studies together, as we'll talk more about later. The last thing to leave you with, though, last thing I want to say about odds is to bring us back to where we were in the section where I talked about prevalence and I talked about proportions. And I made a big point back then that if you have a small risk, say less than 10%, the value for the risk and the value for the odds are going to be very similar. So if you're doing a study and you're following people up to see who developed the disease and you're measuring estimated risks in these two groups, cumulative incidence, and both numbers are small, and you take the ratio of those to calculate a risk ratio, numerically you're going to get a very similar answer to the value for the odds ratio. Because for a rare outcome, a small risk is approximately the same as odds. So therefore, if both of my risks are small, their risk ratio, is going to be approximately the same as the odds ratio. Now that wasn't true in this headache study. Risk ratio was 2.0, odds ratio was 2.5, because the outcomes developing headaches was not that uncommon. But for an uncommon outcome, if one of you measure odds and report odds ratio and another you report risks and report risk ratios, your two values are going to be very similar. Well, that's all I wanted to say about odds ratio, and I'll see you next time.